We're going to look at another type of probability distribution. This is a discrete random variable distribution. What we're doing is we're putting probabilities into a list of numbers. When we're putting in a list of numbers, we're going to be looking at a couple different rules for probability distribution. One is that every probability has to be in between 0 and 1. Also, all of the probabilities have to add up to 1. So however many probabilities there are, those probabilities always have to add up to 1. Also, we can't have a probability that's a negative, and we can't have one that's over 1. So all of them have to be in between 0 and 1. Now, when we're looking at our first example, what we're going to do is we're going to decide if this probability distribution is possible or not. So we have our two rules. One, are all the probabilities in between 0 and 1? And we see that that would be yes. Second rule, do they all add up to 1? 1 6 plus another is 2 6, 3 6, 4 6, 6 6, which adds up to 1. So our answer is yes. Now, if we're looking at letter B, we're going to do the same thing. We're looking at each of our probabilities. Are they in between 0 and 1? And the answer is no. This one's below 0. This one's above 1. So our answer is no. And we have to state why. Because there are probabilities that are over 1 and less than 0. Now, if we're looking at letter C, does it meet the first criteria? Are all of them between 0 and 1? And when we're looking at each of them, we would say yes, it meets the first criteria. If we're looking at the second one, does it add up to 1? 0.6 and 0.2 is 0.8, 0.9, 1, 1.1. That adds up to 1.1. So the answer is no. The probabilities have a sum more than. So that's how we determine if the probability distribution is reliable or not. Now what we're going to be doing is we're going to be looking at probability distributions and we're going to be solving them. Now, if you're looking at our example 2, first thing that we notice is we don't know what's in there. Now, if it's a true distribution, it has to add up to 1. So what we're going to do is we're going to add up all of the probabilities, 0.41, 0.22, 0.14, and 0.12. When we add them all up, what we're going to do is we're going to come up with a sum of 0.89. So that means that in our table is 0.11 because all the probabilities add up to 1. Now we're going to be answering the questions. What's the probability that it's equal to 1? 0.22. What's the probability that it's less than 2? Well, if it's less than 2, that means that we include both of those. Those are both less than 2. So that would be 0.63. And for the next one, what it says is greater than or equal to 2. Since it's an equal, then that means that we include the 2 and everything greater than 2. So when we add up each of those, what we get is 0.37. Now for the last one, what we have to do is we have to show that it's either 3 or 4. So 3 or 4. And that right there would be 0.23. Now, looking at example 3, we're going to do the same thing. First thing that we're going to do is we're going to add up our probabilities. So we have the 0.17, we have the 0.09, we have the 0.05, and we have the 0.02. When we add it up, what we're getting is 0.33. So if that's 0.33, what we're going to do is we're going to subtract it from 1, and that gives us 0.67. Now what we're going to do is answer each of the questions. Equal to 0, 0.67. Now if we're looking at the next one, it's less than or equal to 1. So that includes 1 and less than 1. So when we add it up, we get 0.8. Greater than or equal to 3. That includes 3 and greater than 3. And for the last one, what we have to do is we have to figure out if it's 1 or 3. So what we have is 1 and then 3. And when we add that up, what we get is 0.22.